In this section, we're going to be looking at how we determine the formula of a compound. This is actually what we're going to be doing in the lab for this unit. So there are two different types of formulas that we can see for a compound. The first is the empirical formula. And the empirical formula is the lowest whole number ratio of each element in a compound. So for example, here's my actual compound, C3H6. If I was writing the empirical formula for it, I would simplify this ratio. 3 goes into 3 once, so it's C1. 3 goes into 6 twice, so it's H2. Now the empirical formula isn't actually very useful, but it's usually what we determine first for an unknown compound. And that's what the picture is above. Here I've got my sample. I'm injecting oxygen into it because what I'm actually doing is I am burning my sample. And then what I'm doing is I'm going to collect the stuff that forms, and based on what forms, I can determine the percentage of different elements in my compound to start with. This is one way I can do it. There are actually several other ways. We're going to heat our sample to determine the empirical formula, but there are lots of different ways to figure it out. But it's the lowest whole number ratio, okay? The molecular formula is actually this one, okay? It's the exact formula for a compound. So this is the compound I want. I wouldn't say, go get me some CH2. I'd say, go get me C3H6, okay? So when we're talking about empirical formula determination, okay, what we're going to be doing is we're going to be doing several steps, okay? So usually we're going to be given percentages of elements in our compound because we're figuring that out based on what forms. Sometimes we're given grams. But the easiest way to do the math, base the calculations on 100 grams, okay? So if I have 60% of 100 would be 60 grams. If I had 30% of 100 would be 30 grams. Makes my math a little bit easier, okay? So step 1, I change percentages to grams. Step 2, I'm going to change grams to moles. Now I have to do this for each element. After that, I'm going to divide the number of moles by the smallest number of moles to get whole number ratios, okay? If I don't get whole number ratios, then I need to make them whole number ratios because the empirical formula is always a whole number ratio. So what I will do is I'll multiply by an integer to get whole numbers. Sounds kind of confusing, right? So let's take a look at what this actually will look like. Okay. So this talks about molecular formula. We'll do that in a second. Let's look at example 8, okay? So here I've got an unknown compound. My unknown compound is 71.6% chlorine, 24.27% carbon, and 4.07% hydrogen. All have to do 3 different calculations. One for chlorine, one for carbon, one for hydrogen. So I've got 71.65%. Remember, I make that grams of chlorine. 24.27%. Remember, if I assume it's out of 100, that would be grams of carbon. And 4.07% hydrogen. So if it's percentages, I just ignore the percent and write grams. If it's already in grams, I'm golden, okay? So step 1, change my percentage to grams. Step 2, change my grams to moles. So I have to do the same calculation for all 3 of my elements. I need to make grams go away. So grams are going to go on the bottom. I need to change to moles, so moles are going to go on top. Okay, so remember, anytime I see grams, I need to look at the periodic table. Okay, so chlorine is 35.45, and these, it helps not to round usually. The problems usually base it off of the exact number, and so your numbers will come out a little bit better if you don't round. So 35.453 grams of chlorine is equal to 1 mole. Carbon is 12.011. So 12.011 grams is equal to 1 mole. And hydrogen is 1.088. And that's equal, 1.008, and that's also equal to 1 mole. Okay, so now what I'm going to do is I'm going to calculate my moles. Plug this into my calculator. I get 2.0209. I'm not going to worry about sig figs yet. It'll make my life easier. This one, I get 2.0208. This one, I get 1.99. Oh, sorry. No, I don't. I get 4.0376. Okay. So step 2, I change my grams to moles. Step 3, I find my lowest number of moles. So 2.02, 2.02, 4.03, 2.02 is smaller, and 0.8 is smaller than 0.9. So I'm going to divide each of these numbers by my smallest number of moles. Okay, since all of these are moles, I'm getting rid of my units. Okay, so 2.0209 divided by 2.0208, I'm going to get 1. 2.0208 divided by 2.0208, I get 1. This one, if I plug it into my calculator, I'll get 1.998. Since this is really, really, really close to a whole number, I'm going to round that to 2. Now, if it's not close to a whole number, if it had been 1.5, then I would have to multiply by an integer to turn it into a whole number. But this is basically a whole number, so I don't have to mess with it. So for the empirical formula, I've got chlorine for 1, Cl1. Carbon is 1, C1. Hydrogen is 2, H2. This is my empirical formula. It is the lowest whole number ratio. Well, again, the empirical formula isn't always super helpful. I want to find out what my actual formula is, and my actual formula is the molecular formula. So here's what I'm going to do to figure out my molecular formula. I've already found the empirical. So now I need to compute the mass for my empirical formula. So I want to find the molar mass. So here's what I'm going to do. Cl1, C1, H2. Cl, I said weighed 35.453. And I only have one of them. Carbon weighs 12. And I've only got one of them. Hydrogen weighs 1.008, and I've got 2 of them. So this whole thing adds up to be 49.47 grams. Okay? So I found the molar mass. Now what I want to do is I want to find the ratio. The molar mass for my actual compound compared to my empirical formula molar mass. So here they tell me the molar mass for my actual compound is 98.96 grams per mole. That's the actual molar mass. I'm going to divide that by my empirical formula molar mass. (98.96) divided by 49.47. When I plug that into my calculator, I get 2. Well, what does that mean? Here's what I'm going to do now. I'm going to take my empirical formula and I'm going to multiply it by my ratio. So my empirical formula was Cl1C1H2. I'm going to multiply that by 2. So my actual, I'm going to switch colors because it's getting a little messy here. My actual molecular formula, 1 times 2 is 2, so Cl2. 1 times 2 is 2, so C2. 2 times 2 is 4, so H4. This one's my empirical, this one's my molecular. And remember, this 2 came from the ratio of my molar mass to my molar mass of my empirical formula. Okay? So take a second and solve example 9. Example 9 is 43.64% phosphorus, 56.36% oxygen. Solve for your empirical formula, and then they tell you the molar mass is 283.88 grams per mole. Solve for your molecular formula as well.